Today we will continue with kinematics. We'll be discussing a problem from kinematics. This is from JEE Mains 2019, and kinematics we know we deal with the velocity, acceleration, displacement, etc., etc. Right? We don't focus much on the forces or energy behind the picture. We'll be calculating. We'll be dealing with mostly with the velocities and all. Right? So this problem is also from kinematics. Let's see the question first. A body is projected once again. uh, a body is projected at time t equal to 0 with a velocity 10 meter per second at an angle of 60 degree with the horizontal. A body is projected at t equal to 0. That means at the very beginning a body has been projected with a velocity of 10 meter per second by making an angle of 60 degree with the horizontal. Okay, so let this be the body. Okay, and let this be the horizontal, and this body is projected at an angle of 60 degree with the horizontal. Okay, it was projected at an angle of 60 degree to the with the horizontal, and it went like this. Okay, this angle is 60 degree, so let me mark it. This angle means the at the very beginning the tangent was something like this. Okay, this angle at the very start, this angle is 60 degree. Okay, that is the first sentence. A body is projected at t equal to 0 with a velocity of 10 meter per second. So the initial velocity was 10 meter per second. Okay, the radius of curvature of its trajectory at t equal to 1 second is r. Okay, fine. That means, say after 1 second, suppose the body comes here, body reached here. Okay, it was started from here. In 1 second it reached here. Okay, let this be t equal to 1 second. At this point, the radius of curvature is r. Okay, what does it mean by radius of curvature? Let me tell you. Actually, at every point, the body, each point, it will have unique locations, right? Right now it is here. Sorry, right now the body reached here. At this point, the velocity, it has got a velocity, say this is its velocity. Okay, at this point the particle could be assumed to be part of a circle. Okay, at this point it could be assumed to be part of a circle with a radius r. At each point it will be part of some circle. It's not don't think that this purple color is a part of a circle. It's not like that. It's a projectile motion, it's not a circular motion. What is being conveyed here is, at every point, say at this point, if you take the tangential velocity, it will be like this, right? At this point its radius will be perpendicular. At each point the radius will be perpendicular to its instantaneous velocity. So at each point it will have its own center. Okay, right? So say suppose you take this point here, the velocity will be, instantaneous velocity might be like this, then its radius will be like this. The center we don't know, the value of r and all that depends on its velocity and all. Okay, but it could be assumed to be part of a circle. Okay, that circle's radius is taken as r. The radius of curvature of its trajectory at t equal to 1 second is r. Remember, at each second, at each moment, the radius will be different, the center will be different depending on its current position. The next thing is neglecting air resistance and taking acceleration due to gravity g equal to 10 meter per second square, determine the value of r. Okay, so in this question I would say the most important thing is to understand this part, the radius of curvature at t equal to 1 second, okay, is r. That thing has to be understood. What does it mean? It means that at each position, at this position it may have a radius. How will be the radius? The radius will be perpendicular to its instantaneous velocity. And where will be the center? That we don't know. We need to determine that. Okay, here we are asked to determine it at t equal to 1 second. Okay, so at this point the velocity might be like this, horizontal. Then the radius will be along this line, where we don't know, we have to determine. So in this question it is asked at t equal to 1 second what is the radius. That is the question. It's very important to understand the question first. So let me read the question again. A body is projected at t equal to 0 with a velocity 10 meter per second. A body is projected from here, okay, with an initial velocity t equal to 0. At t equal to 0 it has a velocity of 10 meter per second. That means its initial velocity is this one, 10 meter per second. Okay, and it is projected initially with an angle of 60 degree. Okay, fine. The radius of curvature of its trajectory at t equal to 1 second is r. So this is not r. These are for your understanding I am explaining. Right now this is the t equal to 1 position. The radius at this moment is r. Okay, we are asked to determine this radius r, neglecting air resistance. You can neglect air resistance, and you can take g equal to 10 meter per second square. So it's a nice question. Let's try to understand. Okay, so let me redraw the whole thing again. Suppose this is the trajectory of our particle. This is the, we are concerned only at this position. This is a random position, but this position is at t equal to 1 second. Okay, and at this moment it has got a radius. What is its radius? Its radius is like this. How will you draw the radius? For drawing the radius, first you need to draw the velocity vector. Suppose this is the velocity vector, then this will be the radius capital R. Okay, we don't know its value. Okay, so I am putting here, this is radius R. We are asked to determine this value. Okay, nice question. So how to determine that? Let's see. So at this moment it has got a tangential velocity v, and it has, at this moment it could be assumed to be part of a circle with radius r, right? That's why we put a radius r. Okay, then I would say v square by r, v square by r must be its. So at this moment you can assume it to be like a circular motion with the radius r. Okay, it is executing a circular motion with a radius of r, something like this. Okay, so that v square by r must be equal to its centripetal acceleration a. That this expression we all know, right? What is centripetal acceleration? Centripetal acceleration is the acceleration along the radius of a body which is executing a circular motion. So at this moment you can assume our particle to be executing a circular motion like this. Okay, something like this. Okay, and we know v square by r for a circular motion will give you the centripetal acceleration. That centripetal acceleration will be along its radius, right? So the direction of centripetal acceleration is along this radius. Okay, So what we need to determine? We need to determine the radius, right? So radius, let me write, radius is equal to v square by centripetal acceleration. Radius is equal to v square by centripetal acceleration. So what we need to determine is the radius. So in order to get the radius, what we need to know, the velocity at that moment, the tangential velocity at that moment, and the centripetal acceleration. Okay, so these two. So basically r becomes functions of v and a. If we know v and a, we can calculate r. So our question gets reduced to determining the instantaneous velocity at t equal to 1 second. What is the instantaneous velocity? What is the centripetal acceleration? If we get these two values, we will get the radius. Okay, hope it is clear. This is the main crux of this problem. You should understand centripetal acceleration, you should understand radius of curvature, these things. From this we can get the radius of curvature. Okay, so let's see how we can calculate v square by a, how we can determine each time v and a. Okay, so let me say at this moment, at this point, the particle has a horizontal velocity vx, okay, and a vertical velocity vy, isn't it? It's a two-dimensional thing, right? So this velocity, the velocity can be split into vx and vy. So if we get vx and vy, we can determine v, right? So first let's determine vx and vy. So v, how we are going to determine? We'll determine v by determining vx and vy. So what is vx for this body? You know, let this be the initial velocity u. Let me take this as u. Okay, let this angle be alpha. Okay, what will be the velocity at this point? The velocity will be two components, vx and vy, ux and uy, right? That I am calling as vx, vy. So what will be vx? Vx, see here, vx must be equal to, for a body under motion, v is equal to u plus at, right? And let me apply this equation. Let me apply this equation for this horizontal motion. Okay, the body has come from this position to this. If I consider only the horizontal motion from here to here, I can apply this equation, v equal to u plus at. Vx is equal to ux plus ax into t. Okay, what is ux? Ux is the horizontal component of initial velocity. What is the horizontal component of initial velocity? 10 cos 60, right? So 10 cos 60 plus, what is ax? Ax is horizontal acceleration. Is there any horizontal force acting? Acceleration always comes when there is a force, right? So as the particle moves horizontally, we know the projectile motion consists of two motions, horizontal, vertical, right? X, y. Here my question is, what will be ax? Is there any acceleration being experienced by the particle in horizontal direction? If there was a air resistance, suppose this was a initial position of the particle, it is being thrown like this. If there was air resisting this particle, then there would be a force in opposite direction. If there is a force, then there will be acceleration in opposite direction or in x direction. Right, but here there is no air resistance. If there is no air resistance, then ax must be 0. If there was air resistance, then there will be air resisting this motion. Okay, the particle was coming here, but the air was resisting it in this direction. Then there would have been a horizontal force. Then there would be a horizontal acceleration ax. But here in this case, there is no horizontal acceleration, so ax must be There is no horizontal force, so Ax must be 0, right? So this term becomes 0. So plus 0 into 1. So it becomes what? It becomes simply Vx becomes 10 cos 60. 10 into what is cos 60? Cos 60 is 1 by 2. So Vx become 5 meter per second. Remember, we need just V and A to get the radius, right? Out of that, for V, we need Vx and Vy. Of that, Vx is clear. Vx is 5 meter per second. Okay, that is one. Next, I need to determine Vy. What is Vy? Vy is velocity at this point in vertical direction. So let me again apply the same equation. What is it? V equal to u plus at. Let me apply it for y direction. Vy is equal to uy plus ay into t, right? So Vy is equal to, what is uy? What is uy? 10 sine 60, right? In this direction. Okay, so it must be 10 sine 60 plus ay into t. What is the vertical? The particle was here, it is being thrown like this, it reached here. Okay, it is going like this. What is the acceleration experienced by the body in y direction? This is y direction. Okay, this is x direction. In y direction, to determine the acceleration, you see what are the forces acting in y direction. There is only one force acting in y direction, that is gravitational force. Okay, so what is the acceleration because of that? What is the magnitude of force? Mg, right? So what is the acceleration right now experienced by the particle in vertical direction? It is only g. So Ay is g. There is no doubt about it. So plus g into t. But there is one thing. What is y? Y is this direction, right? But where is our y? Is like positive y is this direction, negative y is this direction. This is negative y. So here our g is acting in negative y direction. So this must be plus minus gt. So it becomes 10 sine 60 minus g into t. G is 1. So 10 into sine 60 minus 1. What is sine 60? Sine 60 is root 3 by 2. Root 3 by 2 minus 1 meter per second. You don't have to simplify, you can just put it like that. So Vy is equal to 10 root 3 by 2 minus 1. So we got Vx and Vy, right? If we have Vx and Vy, that means we have Vy. Actually Vy, you can see the equation. Root 3 by 2 will be less than 1. So this happens to be a negative value. This happens to be a negative value, right? This happens to be a negative value. Root 3 by 2 minus 1. So this happens to be a negative value. That means our Vy is in which direction? Vy is in minus y direction, negative y direction. So Vy is this, and Vx is positive value 5. So this must be Vx. Okay. So what is V then? V is the resultant of these two, right? What is V? Because this is the V which is being split into Vx and Vy. Okay. So V is the resultant of these two, which is this one, right? How did you get that? Yeah, we know vector addition. So this is V. That V is equal to square root of Vx square plus Vy square, right? So V is equal to square root of, what is Vx? 5 square plus what is Vy? Vy is 10 into root 3 by 2 minus 1. So 10 square into root 3 by 2 minus 1 the whole square. So if you simplify this, you will get V, this much meter per second, right? So you got V. Then what you need? So V is over. V is over. Now you just need acceleration, which is which is that acceleration? That is centripetal acceleration along this line, right? Along this radius. Okay, so how to get that? So if you look into the whole scenario, you understand that there is only one acceleration, which is that it is nothing but the acceleration due to gravity in the vertical direction, in the direction of negative y. There is g, right? That means there is an acceleration in this direction, okay, g. So what, that is the only acceleration which is there in this picture. So right now what I need is acceleration along this line, along this direction. So that can be only, this a can only be a component of g, because there is only one acceleration present here, that is g. And a must be, so a must be only a component of that. So if this is theta, then what must be a must be g cos theta, right? A must be, this a must be g cos theta. So the value of g I know, so I need to know only theta to get the value of a, right? How to get theta? Look here. Here, if you just observe, you will understand. What is this angle? This is 90. The angle between A and V is 90, because A is along radius, V is the resultant velocity, tangential velocity. The velocity and radius will be always perpendicular in the case of a circular motion, right? So this is 90 degree. And who else is also 90? The angle between Vx and Vy. Vx and Vy, that is angle between Vx and G is also 90 degree. This angle, okay. This, the angle between these two is also 90. So right now I put this as theta, okay. Then what must be this angle? This must be 90 minus theta, right? Why? Because this is theta. This whole angle is 90 degree. So this must be 90 minus theta. Then what must be this angle? This whole angle is 90 degree. Vx and Vy is 90 degree. This is 90 minus theta. So this must be also theta, right? So this, if this is theta, then this is also theta. What is this? What is theta here? If you observe this diagram, you understand this is what I wrote as theta. You see, theta came out. I defined theta as this one, okay, angle between A and G, okay. But if you analyze properly, you will understand that theta is same as the angle between, the theta is same for the angle between V and Vx also, okay. So V and Vx we have here, this is V, this is Vx, this angle is theta. Then what is tan theta? Tan theta is equal to opposite side by adjacent side. Okay, what is this opposite side? This opposite side is nothing but Vy. So Vy by this horizontal length. What is this horizontal length? Vx, right? So tan theta is equal to Vy by Vx, right? But let that be here. So Vy by Vx will give you tan theta. Let this be here. Let me go back to the equation for radius. What is radius? Radius is V square by A. Let me write it again. Radius is equal to V square by A. That is V square by, what is A? A is G cos theta, right? So V square by G cos theta, okay. R is equal to V square by G cos theta. So is equal to square root of Vx square plus Vy square divided by 10 into, what is cos theta? Cos theta, if you see from this triangle, what is cos theta? Cos theta is adjacent side by hypotenuse. What is adjacent side for this theta? For this triangle, what is adjacent side? Vx is the adjacent side. What is hypotenuse? V is the hypotenuse, right? So 10 into Vx by V. Here, if you see, R is equal to V square root of Vx square. What is Vx? uh, Sometimes when you see the equation you may think that you need it cannot be solved without calculator, but it's not like that. It could be solved without calculator. We can finally at the end we can simplify everything. Most of the JEE questions you don't need calculator, but it appears to be like you can solve it only if you have calculator, but that's not the case. You can do it without a calculator very easily. So Vx square, Vx we know what is Vx. Vx is here 5. Okay, what is Vy? Vy is this one, 10 into root 3 by 2 minus 1. So 10 square into root 3 by 2 minus 1 the whole square divided by 10 into what is Vx? 5 divided by what is V? V is again this one, square root of 5 square plus 10 square into root 3 by 2 minus 1 the whole square. So that will give you the radius in meters. It will come, if you solve it, it will come out to be roughly around 2.8. Okay, so um, that's for that's for this question. Hope you understood this. So the answer is option B. Option B. You can solve it by your own. Don't hesitate, even if you see that, even if you think the question is so big, question is not easy, don't think like that. Just approach the question, be open to the question, try to explore the question from all that you know. Whatever you know, go from there. Okay, so that's how you explore, you unwind, or you figure out how to solve this. Thank you. Please subscribe, share. Come again tomorrow. See you. Thank you.